Now we're going to move on to graphing of trig functions, and we're going to spend a lot of time with sine and cosine, and then we will cover the other trig functions as well, but sine and cosine are by far the most important in terms of graphing. And also, if you understand sine and cosine, graphing secant and cosecant are very easy. Okay, first a little demonstration though, how these relate to the unit circle. So here I have a unit circle. I have theta, it's at 0 right now. I can animate theta so it'll move around the circle, but we're going to start it at 0. Now we know that sine is the y values. I'm going to move this up a little bit so you can see that. So what we're going to do is, here are the y values as I go around the circle. Again, here so you can see those y values changing. But what we're going to do is we're going to plot those y values where now the x-axis is going to be the angle theta and the y-axis is going to be the y values from the unit circle. So watch what happens as I do this. As I plot these values, I create a curve. And what I did right here, I know I stopped it a little bit short, but this is essentially one revolution around the circle. What that is one period of the sine function. So if we keep going, animate theta, so I'm going to go a little bit quicker. So we can see that the curve keeps going forever, and then you'll see now it's going to reverse and it's going to go towards negative angles once it catches up. So we're still positive, 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 now negative. So it goes in that direction as well. So that is our sine curve, or that's how we get the sine curve from the unit circle. We can do the same thing with cosine. So if I show that, I show that, show that. Cosine is the x values. So right now the x value is at 1. So now what's going to happen is as we plot this, notice that this point already started up here. So as we plot this, again, the x-axis is the angle, and now the y-axis is our x value from the unit circle. So it is the value of cosine at the angle. So now if I move theta, now we can see this is what the cosine curve looks like. So again, boom, that's one period of the cosine curve because that is one revolution around the circle. So that's what the cosine curve looks like for one period. But again, if I keep going, then we can see cosine keeps going forever and ever. And also, I'm going to put in the y values now as well and plot both of them at the same time. So we can see if what this is the sine and the cosine curve on top of each other. And they are actually the exact same curve, just shifted over slightly. Remember the co-function identities? How it was pi halves minus theta, that's a shift of pi halves. And so if you picture, if I shift this pi halves to the right, it is the sine curve. Or if I shift the sine curve pi halves to the left, it's the cosine curve. Fun stuff. Alright, so that was how we can create the sine and cosine curve by basically unwrapping the unit circle, where again, now we have to keep in mind the difference between x and y. That when we're talking about the unit circle, cosine is the x values and sine is the y values. But when we're graphing the functions, the x-axis is the angles and the y-axis is the output of any of the trig functions. Alright, now we're going to define a couple of terms. So amplitude. Amplitude is represents half the distance between the maximum and minimum value of the function. Another way to think about that is half the distance of the range. An important thing to note is that it is a distance, therefore it has to be what? It has to be positive. Very good. The period is the distance of one complete cycle. Again, important to note that it is a distance. So the standard period for sine and cosine is 2 pi, but that can change. So here, if we have some generic function, y equals a sine bx, or y equals a cosine bx, I've given 4 different examples. These are on your sheet or on your packet as well. And I've given the period and the amplitude for each example. So the generic function y equals sine x and y equals cosine x both have a period of 2 pi and an amplitude of 1. The function y equals 2 sine 3x and the function y equals 2 cosine 3x have a period of 2 pi thirds and an amplitude of 2. And then we can see down here, negative 5 sine pi x, negative 5 cosine pi x have a period of 2, amplitude of 5, y equals 3/4 sine x over 2, and y equals 3/4 cosine x over 2 have a period of 4 pi and an amplitude of 3/4. Sorry, that got cut off a little bit, but it is in your packet. So what I want you to do is, looking at those and using your knowledge, your previous knowledge of graphing trig functions, I want you to come up with, how do we find the amplitude of a sine or cosine function of this form, and how do we find the period of a sine or cosine function of that form? And because it's the same for sine and cosine. How you find the amplitude and how you find the period are the same for both of them. Okay, pause the video and do that. Alright, so hopefully you came up with some good explanations for how to find the amplitude and the period of the sine and the cosine function. Just to go over the basic functions again, so this was one of the examples back here, so that's why I'm going through it a little bit quicker. But we know that the amplitude of this, of y equals sine of x and y equals cosine of x, is 1. The period is 2 pi. Remember, the period is the distance of a complete cycle. The domain and the range, we should know this already because we talked about this earlier on in the unit. The domain of the sine and cosine function is negative infinity to infinity. Let's talk about that real quick. So and let's talk about the range real quick too. The range is negative 1 to 1, including negative 1 and 1. So if I look at these graphs, remember they are going to the left and to the right forever, so that's why the domain is negative infinity to infinity. The other way to think about that is, remember, the domain is the input. The input is an angle. There are an infinite amount of coterminal angles, so therefore the inputs, there are an infinite amount of them. The range is the output, and the unit circle never goes above 1 or below negative 1 in either the left or right or up or down direction. And we can see from the graph here that the graph keeps bouncing between negative 1 and 1. But it does include negative 1 and 1. So that's how we get our amplitude, or that is what our amplitude, period, domain, and range are for the standard or basic y equals sine of x and y equals cosine of x functions. Now, a little more generic function, y equals a sine bx minus c, and then plus d, or y equals d plus a sine bx minus c. So now this is going to include shifts as well. So our amplitude and our period, hopefully you came up with a method to find those that is correct. Our horizontal shift, or our phase shift, we are going to set bx minus c equal to 0 and solve for x. This is going to give us our horizontal shift and our starting x value. Those are the same thing for assigning a cosine function. When I'm saying starting x value, again, the graph goes on in both directions forever, but if we're going to actually graph it, we need to have a place to start. The vertical shift is going to be the d value. So if we look at these equations, that's just the number that we're adding or subtracting outside of the parentheses. Graphing strategies. Okay, so one period is going to be 5 points. So for sine, you can see this on the board in the classroom. One period is going to look like this, and for cosine, one period is going to look like that. Now, 2 periods is going to be 9 points because the last point of the first period is going to be the first point of the second period. So again, this was sine. This is, oops, cosine. Okay, we need to know that because that's going to be what we're trying to find, is those 5 points. So our strategies are, first, find vertical shift. This is going to be your new horizontal axis. So if there is no vertical shift, then the x-axis is your horizontal axis. Then you are going to find the amplitude, then the period, then the intervals, and I'll talk about that in a sec. And the intervals are the period divided by 4. So what the intervals do is they give you the distance between, the horizontal distance between these 5 points. So that's why we divide the period by 4, because if this is one period, I can see there's 1, 2, 3, 4 segments. So there's 4 segments between the 5 points. And then last, we are going to plot, then we are going to find the starting x value. And then last, plot the points. And again, what you need to know is you need to kind of have it ingrained in your head, the image of a sine curve for one period and the image of a cosine curve for one period. Because once they get beyond one period, they look very similar, because again, they are the same thing. All right, let's do an example. So I want you to go ahead and find all of that information. So once you find the information, then we'll talk about it and see if you have it correct. Then we'll talk about graphing. So pause the video, find all of that information. Go ahead and try and graph it if you want, but otherwise we'll do the graph part together. Pause the video. All right, so there is no d value. So my vertical shift is 0. My amplitude is 3. The period is pi. The horizontal shift is 0. And my intervals, remember, are the period divided by 4, so that is pi fourths. So now I'm going to graph. I'm going to draw an axis, and when you're doing this, you should do this, make this as easy on yourself as possible. So we're trying to graph 2 periods. I know I'm going to start at 0, and then I'm going to do 1, 2, so that's, 1, 2, 3, 4, 5, 6, 7, 8, 9, because I'm going to have 9 points. That's 0, this is pi fourths, pi halves, 3 pi fourths, pi, 5 pi fourths, 3 pi halves, 7 pi fourths, and 2 pi. My amplitude was 3, so I'm going to go up 3 and down 3. So again, what I mean by make it as easy on yourself as possible, just space everything evenly and then label it. That's what I'm looking for here. Now this was a positive sine curve, so I'm going to start here, up, here, down, here. That's one period, then up, here, down, here. 2 periods. Now just draw a nice curve. Boom. There we go. Alright, I want you to try to do this now. So here I want you to find that information and graph it. Pay attention to -3. How does a negative in front of a function affect the transformation of the function? So pause the video and do this. Alright, here again our vertical shift was 0. Our amplitude is 3, but the negative is going to affect the graph. The period is 2 pi. Our horizontal shift was pi fourths. We get that by setting what's in the parentheses equal to 0 and solving for x. And our intervals are pi halves. So now I started at pi fourths, and then I have my 9 marks, adding pi halves each time, going down at -3, up to +3. But because it was a -3, I start below the axis. So I flip or multiply the cosine function by -1. Plot my points, and then draw my curve. All right, go on to part 2 for the last example.